Hello everyone, I am Smoshi and in this tutorial video, I'll be one of the learners with you.
Hello everyone, I'm Guiller Angelo Hermoso.
Hi, I am Michelle.
And I'm Anne with an E. In our last tutorial video, we learned the process of approximating areas under curves using the Riemann sum. This time, we'll tackle a new mathematical concept and tool, the definite integrals.
Yes, and we'll cover the fundamental concept and rules related to it. But before we dive in, let's start with a recap. In calculus, integrals are used to measure the area under the curve. This is important because it helps us understand how quantities change over time. And the process of finding integrals is called integration. There are two types of integrals: definite, the one our group will be discussing, and indefinite integrals. The simple difference between the two is that a definite integral gives a numerical value for the area between 2 points, while an indefinite integral gives a function whose derivative is the original function.
Definite integrals represent not only the function but also where the function begins and ends on the axis, defined by the interval a, b, where a and b is the upper and lower limits respectively. Kaya po siya tinawag na definite ay dahil we're integrating the function at a certain bounds, written as. This notation sums up the infinitesimally small areas under the curve of f of x from x equals a to x equals b. Let's go ahead and break down its parts. Here, the stylish s for sum is the integral symbol. A equals the lower limit of our interval, and b equals the upper limit. F of x is called the integrand, while dx is the integrating agent. And that's all basic notations you need to know. Integrals have several interesting properties that makes the calculation more efficient.
For our first property, we have the reversal of limits. Reversing the limits of integration changes the sign of the integral. This states that if we switch the upper and lower limits, the integral's value is the opposite of what it was before. So, if our integral is positive, reversing the a and b values will make it negative. And if it is negative, the reversal will lead to a positive integral. The integral over an interval of zero length is 0. Basically, if our upper limit is equal to our lower limit, our function has no length. So, its definite integral will always be 0. For example, if we'll evaluate the definite interval of 9x squared from 9 to 9, we'll get 0.
The integral of a constant is equal to the constant times the difference between the upper and lower limits. To simply put it, if a function is constant, meaning it doesn't change, finding its integral means you just multiply the constant by the length of the interval. For example, the distance between the two endpoints of the interval, which is like finding the area of a rectangle. Let f of x equals 5 squared. According to this property, we multiply 5 squared with the difference between our upper and lower limit. That is 25 times 4 minus 1 is 3. So we get 75. A constant can be factored out of an integral. When integrating a constant multiplied by a function, the constant can be pulled out of the integral.
This property is pretty straightforward. When integrating a sum or difference of functions, we can integrate each function separately and then add or subtract the result. Say we have 3x plus 6x squared. Applying the sum difference property would look like this.
Along with those basic properties mentioned, we have one for even and odd functions, which states that for functions that are symmetrical or even, the integral over an interval centered at 0 can be simplified as 2 times the definite integral of fx from 0 to a. Meanwhile, For functions that are not symmetrical or is odd, the integral over this interval is 0. Now, this last property involves positive and negative areas. If you can still recall, on our last video we discussed the net areas. When the function is above the x-axis, its integral represents a positive area. And when it is below the x-axis naman, its integral represents a negative area. Now, according to this property, if we encounter a function na nagko-cross over and under the x-axis within the interval a and b, tulad ng nasa illustration, we just subtract the negative from the positive. That's all there is to know for the properties. At this point, let's learn how to evaluate the definite integral of a function using the fundamental theorem of calculus. The fundamental theory of calculus, or FTC, is an important concept that connects differentiation and integration. It consists of two parts, with the second part often being used to solve definite integrals. FTC Part 2 states that if uppercase fx is the antiderivative of lowercase fx, then the definite integral of a function fx from a to b is equal to the difference between f of x's antiderivative at b and its antiderivative at a. Let's go ahead and apply this theorem to find the definite integral of function 5x from 1/2 to 7/2. Remember that according to the constant multiple property, we can factor out the constant. This leaves us with an integrand of just x. Next, we get the antiderivative of x using the power rule of integration to get x squared all over 2. And then, we'll evaluate the antiderivative at our given limits. Substituting in our a and b values, our f of b becomes 49 over 8, while our f of a is 1 over 8. Since they are similar fractions, we can subtract the numerators. That is 49 minus 1 equals 48, which is divisible by 8. So simplifying this leads us to 6. But wait, we still have that 5b factored out. Our final answer will be 5 times 6. This means that the definite integral of 5x from 1/2 to 7/2 is 30.
For example 2, we have function 2v squared plus 4v that we're going to evaluate from 1 to 4. Our solving process will be the same as what Anne did. First, let's use the sum difference property to break apart 2v squared and 4v. And let's put the constant outside the integral to simplify our integral. Using the power rule for both functions, v squared will be v raised to the power of 3 over 3 and v is v squared over 2. Next up is evaluating the h antiderivative at their a and b limits. Our f of b becomes 63 over 3 divided to the lowest terms and we get 21, while f of a is 15 over 12. We can now multiply them with their respective constants. 2 times 21 is 42, 4 times 15 over 2 is 60, divided by 2, we have 30. We still have to add both of them together to get the final answers. That is 42 plus 30, leading us to the definite integral value of 72.
Let's evaluate the definite integral of e raised to t from 1 to -5. Since our limit of integration is in reverse, we will use the reverse interval property on this function to switch the upper and lower limit of the integral. Next, we get the antiderivative of e raised to t using the power rule of integration. We get e raised to t. Then, we'll evaluate the antiderivative at our given limits. Let's plug in our a and b values into our function. Our f of b is raised to 1, while f of a is e raised to -5. We can further simplify our f of a by applying the law of exponent, turning our negative exponent into a fraction. We can now multiply the negative sign to our answer. Our final answer will be e plus 1 over e raised to 5.
Here, in example 4, we are to evaluate the definite integral of f of x is equal to cos s from 0 to pi. We can see here that both limits are constant and also the function satisfies the condition of a and b being continuous. First, we get the antiderivative of cos s, which is sin s. Then, we apply the FTC or the fundamental theorem of calculus using the formula. We plug in our limits into the function. Sin times pi is equal to 0 and sin times 0 is equal to 0. Finally, we subtract 0 to 0 and we get 0. In conclusion, the definite integral of cos s from 0 to pi is 0. Easy as that. That's the end of our tutorial. It's been fun learning definite integrals with you.
Remember, understanding the properties and how to apply the FTC can make solving these integrals much easier and more efficient. It's a handy concept.
So, if you learned something from our tutorial, please like and subscribe. If you have any questions, just leave a comment down below. Thank you for watching.
Till our next tutorial video, keep integrating. Bye!
Bye!